P1 and P2,
P4
P4 and
ये P4 होगा
954 P2
ऊपर P4 होगा
954 and this one P4 and I. So these are ready queue and the wedding queue, and all these all the information we call it big bookkeeping operation. The book, it should be with the program or with the operating system.
Operating system.
Now your marks. हाँ? क्या करें? Bookkeeping operation. Now let's assume if I have scheduled an OST for you, all of them, your marks will be with me or with you? With me, because I am keeping the bookkeeping and all this. This is sensitive data. Sensitive data should be with the part of the operating system. And operating system decide, okay, which one is currently now in the ready state, which program is now in the waiting state. Similarly, here is another queue, and running is only one program. Maybe this is running mode of processor P1, processor 1, and running processor 2. So let's assume maybe P5 is running a processor and P6 is running a processor 2.
Yes, sir.
Maybe there are two processors, and let's assume there are two processors. Maybe P5 is running, maybe P6 is running. Our operating system is running. So actually, this, if you look at here, so there are the programs that are running, and all these bookkeeping of the state information is stored as a part of the operating system or as a part of the kernel. Now, why this switching is required? Why this time is required?
कि सर वो क्यों वगैरह अपडेट भी तो होगा सर.
Okay, now this switching time is required for what? Switching time is required. Switching time, which is highlighted by this, is required. Why it is required? To update what? Update all queues, automate for bookkeeping. And also, another thing is important. Not only switching is required, but switching is also required for the context switch. Now you are running program P1 and you are suspending that. So you have to return from that. And context switch.
Delocate भी कर रहे हैं memory.
Not delocate. Context switch.
नहीं समझा सर context switch का क्या है?
I told you the context switch in your previous class. The context switch. Now let's see the process program P1 is running, and this is instruction I. This is instruction I plus 1. You execute that instruction. This program P1 is interrupted. Now you have to resume execution from which instruction? Instruction I plus 1. You have to store the context switch.
Yes sir.
Context switch में कौन-कौन सी चीज़ आ जाएगी?
PC yes sir.
एक और चीज़ भी है. Status register.
All active registers
and working registers, if you remember.
Yes sir.
Okay, so actually now it's very much important. Now how much time slot we need to give to each program? If this time slot is larger, now let's assume if we say that this time slot is, now let's say the switching time is 1 millisecond, 1 millisecond. Okay, 1 millisecond, and the time slot that I am doing this is 10 millisecond. And 10 millisecond, and 10 millisecond. What is the advantage of using a smaller time slot?
तो दूसरा प्रोग्राम जो है जल्दी एग्जीक्यूट हो जाएगा.
So actually, if you look at the response time, the response time is good if the time slot is smaller. If you increase the time slot, the response time is slower. Because if the user click on the new program and maybe it's waiting for a lot. Because if it allowed that program to execute for a certain interval.
Yes sir.
For time slot. So if the time slot is larger, the response time is bad. The time slot is smaller.
Response time is good.
The response time is good. But a larger response time has a less overhead in terms of switching compared to
switching overhead.
Okay, so now if you say, if you have 10 time slot.
Yes sir.
10 millisecond, then 1, then 10, then 1. Now, if you have a large time slot, like 20 millisecond, and then 1 millisecond, so the overhead of the switching is less.
Yes, sir.
The overhead, percent overhead is
Less.
Now let's assume if this program requires 50 milliseconds, it requires
50
50
milliseconds.
milliseconds. So it will be allocated 5 intervals. Interval 1, interval 2, interval 3, 4, 5, because the total
ठीक है,
execution time is 50 milliseconds.
Yes, sir.
Okay? But if this program has a time slot of 20 milliseconds, so what will, how many time interval it will have? 20, 20 and then 10. And when after 20, let's assume there is no waiting state or not waiting for any, so assume a scenario there is no waiting of resources. Now if you look at this 20 millisecond, and after 20 millisecond, then it will be 20 millisecond. So in 20 millisecond it will be in running state. When the control is given to other program, it will move from the running to which state? Ready state. Again when the time slot is given, then running. Then again ready. Again running. After third time slot, it will move from ready to halted, and then the memory will be ready. Okay?
Yes.
These are all the sequence of the events. These are all the sequence of the events. They needs to be understood by you. What are the jobs of the operating system, how the bookkeeping is maintained within the operating system, how the control is transferred from one program to another program, what is the context switch, why context switch is important, why we need to switch from one program to another program. I also told you that okay, now there is a context switch because when a program is suspended from by any instruction, if you look at a program consists of instructions. When a program is suspended, so the program needs to be executed from the location from where it was suspended. So we need to store the value of the program on the stack. And each program has its own stacks. Stack of program also. Actually all these stack maintaining and all these things is also managed by the operating system. All these things are done by the operating system. So the job of the operating system is very, very tough, because it has to provide a fail-safe environment for all the program. Because if a program is interrupted, it's not a big problem, but if the operating system is interrupted, it's a big problem.
It's a big problem.
Okay, so the correction of operating system is most disaster compared to the correction of a particular program. So if a program is correct, so operating system will take care of it. It will say, okay, it will not violate the memory protection rules. But if the operating system is robust, so you should feel safe. So there is also a trade-off between the different times. So when we also ask this question, so what's the trade-off? That if we are giving a smaller time slot or a bigger time slot, so these are just different trade-offs. You need to know these trade-offs.